Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about concept of variance and what is variance and what is the mathematical definition of the variance. In many physical problems, the measure of expected value of a random variable does not completely characterize the probability distribution. It may be necessary to find the spread dispersion about the mean values. The quantity used to measure this dispersion is called the variance of the distribution. The variance of the random variable X is denoted by variance of x or sigma suffix x square or simply sigma square. The variance The variance of the random variable or the dispersion of a random variable X is given by or defined as variance of x or sigma x square is equal expectation of x minus e of x whole square or expectation of x minus m whole square, where m or expectation of x is the expected value of the random variable. So the expected value of the random variable, the concept of expectation is already discussed in my previous video. Okay, now here small m or expectation of x is the expected value of the random variable. So this expression is the variance of a random variable, that is variance of x is equal to expectation of x minus m whole square. The mean square value of the random variable, that is expectation of x square. Expectation of x square is the mean square value of the random variable. Variance of x is the variance of the random variable is always non-negative. So that is expectation of x square is always greater than or equal to 0, and the variance of the random variable, variance of the x is always greater than or equal to 0. The positive square root of the variance, is called the standard deviation. It is used as a measure of the spread of the random variable around its mean value. So that is the standard deviation. Sigma is the standard deviation. The standard deviation sigma is equal square root of the variance of the random variable, but variance of the random variable is expectation of x minus m whole square. So standard deviation sigma is equal square root of expectation of x minus m whole square. So for the continuous case and the discrete case, the variance of the random variable is given by or defined as if the random variable capital X is a discrete random variable, the variance of the random variable is given by variance of x is equal or expectation of x minus m whole square is equal for the discrete case. Sigma I is equal to 1 to n xi minus m whole square into probability of xi. And for continuous case, the variance of the random variable is given by expectation of x minus m whole square is equal integral minus infinity to infinity x minus m whole square into probability density function into dx. So these are the equations of random variable x is a discrete type and the random variable x is a continuous type. So any one expression, this expression or this expression, discrete type expression or continuous type expression can be further simplified as, so first I am going to simplifying continuous case expression simplification. So now here in this continuous case expression an RHS side x minus m whole square. So expand a minus b whole square, a square plus b square minus 2ab. So that continuous equation can be simplified as on RHS side x minus m whole square x square plus m square minus 2mx into fx of x dx. So multiplying this density function within the bracket term and applying the integration into each term, we get on RHS side integral minus infinity to infinity x square into fx of x dx plus integral minus infinity to infinity m square into fx of x dx minus 2 into integral minus infinity to infinity mx into fx of x dx. So according to definition of movement about the origin, so movement about the origin for the continuous case, what is the definition? Integral minus infinity to infinity x power n fx of x dx, and n is equal to 2 is the second movement about the origin. So that is integral minus infinity to infinity x square f of x dx is the expectation of x square expression, and this is expectation of m square, and this is expectation of mx according to definition of the continuous random variable definition. Movement about the origin definitions. Variance of x is equal to, the first term is expectation of x square, and the second term is expectation of m square, and third term is expectation of mx. Since small m is a constant, that is the mean value, that mean value is a constant. So expectation of m is m, expectation of mx is m into expectation of x. So m is a constant value. So applying this condition into above expression, we get variance of x is equal to expectation of x square plus expectation of m square is m square. Mean m is the constant value. So m is the constant, expectation of mx is m expectation of x. So e of x is the variance of the random variable. So that variance of the random variable is also denoted by small m. That variance of the random variable is also denoted by small m. So this expectation of the x is also represented by m. So m into m square. So that is equal RHS side, RHS term, expectation of x square plus m square minus 2m square plus m square minus 2m square minus m square. So which is equal to expectation of x square minus m square. So expectation of x square is the mean square value of the random variable or second moment of the random variable. So expectation of x square is the second moment, and it is also denoted as m suffix 2, and m is the expectation of x. So expectation of x whole square. Expectation of x is the first moment of the random variable, and it is also denoted as m1. So variance of x is equal expectation of x square minus m square or m2 minus m1 square. So in this expression, expectation of x square is the second moment of the random variable. Expectation of x is the first moment of the random variable. So this is the derivation and explanation of the variance of the random variable. So this simplification, this is derived from the continuous case of the random variable. Similarly, we can derive the same result for same result can also be verified for a discrete random variable case. So finally, we get same expression for a discrete random variable case also. So that is variance of x is equal to expectation of x square minus expectation of x whole square or m2 minus m1